So with that, no further ado, we'll get started with our presentation, and I'll pass it on to Professor Rafferty to share more about our programs.
And just give me a second to get the laser pointer. Yep. Okay. So we've got several different chemistry programs at Trent University. I do also want to say that typical of Trent, you can do actually joint majors in any combination of degrees as well too. So these are what we're listing here are fairly restricted programs where we define quite rigorously which courses you have to take. But these are not your only options. So for example, there is such a possibility as doing like a joint major in English and chemistry, and that's happened more than once that I'm aware of. So if you want to exercise both sides of your brain, it is possible to do that. These, though, are in particular very popular programs that we actually have a very good course maps for. So they include chemistry, biochemistry, and molecular biology, also environmental chemistry, given Trent's strength in the environment, chemical physics, and forensics chemistry as well too. So what are these programs? There's a lot of these things. A lot of them run out of the chemistry building. And so we have one of the newer buildings on campus. It's got this nice, big, beautiful view of the older part of campus right here, this fantastic banner, so you can't get lost. Basically, if you're new to campus, you're looking where chemistry is, you just look for this big banner here, and you'll find your lab is just around the corner there. But these different programs, these will be the chemistry, abbreviated as CHEM. This is our honors chemistry program, and this is accredited by the Canadian Society for Chemistry. So what that entitles you to do is to become a member of this particular society. So our program is recognized as meeting all the requirements for getting an honors degree in chemistry. We also have chemical physics offered jointly between the departments of chemistry and physics, and also the biochemistry and molecular biology program, which is run joint with biology. Environmental chemistry, that's run joint with the School of the Environment, and forensics chemistry, which is done jointly with forensics. So we have all these different programs and the joint majors that I mentioned before, but they do have some things in common. First of all, they are very heavily laboratory oriented. So we do a lot of lecturings and things like that, but really most of your experience comes from actually working in the laboratory. So this idea of experiential learning, and either working in a laboratory on your own or with a partner, you begin to get a sense for what chemistry really is all about. So you learn much more by doing things than you do actually by listening. Actually, you need a combination of both, but the laboratory experience makes the lecture stuff come alive. So because we do have this focus on laboratory experience, really you have to think about what you're doing, and you get to use all the equipment that we have in our department. And I'm really pleased to say that in terms of resources that we have available for students to work on, we are second to none in terms of the instrumentation that we give to people to work with, and the attention that you would get. I know it's a two-way street as well too. You do have people who are willing to help you, and two ways, teaching assistants likewise would be willing to help you, but you also have to do your part and speak up when you need help as well too. So Trent is a great place because we have small classes and things like that, but you also have to meet us halfway as well too, and we'd be more than willing to help you. So in the first couple of years, you'd be doing labs in your courses, and as you get along in your career, about third year, you can begin to do some more labs that involve more thinking, more independence. And so certain courses, such as the biochemistry laboratories, will offer more scope for independent work. And Ryan can tell you about this as well too, because he actually took this course. And actually in fourth year, you can also do a fourth year thesis project, which if you're interested in doing graduate work, this resembles the kind of independence that you would have at this level. And Sarah is also experiencing this as well right now too, so she can speak to questions like that. So the courses you take is very typical for a lot of universities. Virtually every course at Trent is what's called an H course. It just means it runs for half a year or a single term. So if you look at the course list, they all end in H. So in each term, fall or winter, you would take 5 such courses for a full course load. And so all the level 1,000 to 3,000 chemistry courses, they will have labs in them. COVID threw us off for a loop for a bit, but even during the pandemic, we were doing our best to offer laboratories where we could. And so we're really pleased now that things seem to be getting back to normal. I think for 2022 in the fall, first year chem will more than likely run laboratories as well too. And that will be true for all the second year and third year courses as well too. And the level 4000 courses, your fourth year courses, they do not have labs associated with them. They're all lecture based, that involve presentations, but that's to leave room for people who want to do the thesis courses. And so basically the thesis course, these can be worth anywhere from half a credit to 2 credits. Most students do the 2 credit option because that actually is equivalent to, say, 4 H-level courses. And I'll tell you that doing 2 credits of lab work is always way more fun than doing any 2 possible credits of lectures. So because you're doing your own stuff, you're putting what you've learned in your previous classes into practice. You're working with the professor on a project of mutual interest. And basically, if you're lucky, then you're kind of like turned loose in the professor's laboratory and you can kind of treat it as your own within limits. So we do have all these different programs, and you're going to notice, I'm just going to talk about what you do in year 1, because most of you probably are just, high school students. You want to know, what do I have to take right away? Talking about 4th year projects is, that's fine, but my needs are more immediate. What courses do I take? So I'm going to go through this for all the different programs we offer. And what you'll see is that the common thread of them is that they all involve taking intro chemistry, some physics, some math, which is typically calculus. So that's going to be true for almost all the programs we offer here. You have some sort of variation on these sorts of themes. So there's a lot of repetition then between the course requirements for the different majors. But that's also good too, because it's very common for people to change their major after they get to university. And say if you decide you don't want to be like a chemistry major, you want to be a biochemistry major or something else, you've probably already taken a lot of the courses that you would need to make that transition smoothly. So by having kind of a general first year set of courses, it allows you to kind of skate between these different options if you decide you want to change your interests. So for first year chem majors, you would take our Chem 1000 course. That's our Intro Chem 1. Physics 1001, that's Intro Physics 1. And Math 1110-0H, that's Calculus 1. And in the winter term, basically, you take the winter term portions of those. So our second Intro Chem 2, Intro Physics 2, and Calculus 2. These recommended courses, not all chemistry majors would need to take them, but if you think, well, maybe I would like to be a biochemist, then you would perhaps take these courses because these would be required for the biochem major. Plus, there would be a set of electives. So notice that when you take a full course load per term is taking 5 courses. We've only defined 3 here. The remainder you would take from electives, such as computer science courses, environmental science courses, and all Trent students, regardless of their program, have to take a half credit in one of the approved Indigenous Studies courses. That's the INDG course. So for chemical physics, it's quite similar. Basically, it's the same as what you take for chemistry, just with the addition of this programming course here, this computer science course. And likewise, in the fall, then you would take the same courses that, say, a chemistry major would. And you would, again, take whatever electives you would find of interest. So at least for starters, there's quite good overlap, say, between the chemistry majors and the chemical physics majors. If you're in biochemistry and molecular biology, again, the same thing. You would take intro chemistry. The physics requirements are a bit different here. You have a choice. Biochem majors only have to take a half credit of physics, and that can be either the Intro Physics 1, which is what's underlined, or the Physics for Life Sciences, which is 1060H. I've underlined this one because even though either one of these would do for you, my personal opinion is that this is probably the more valuable course. Because if it turns out that you like physics, then you could then, it doesn't close any doors for you. Because then in your winter term, you could take Physics 1002. It's not required for biochemistry students, but I think it's a useful course to take to have a full year of physics. Likewise, you would take Calculus 1 and Calculus 2, that's preferred. Actually, if you look at the calendar, another option is to take a single credit calculus course, Math 1005H, and then something else like algebra. But what I've shown here, just for the sake of a clean slide, is what the preferred courses would be. Both calculus courses would be more useful for you, especially if you have to take physical chemistry in second year. And I do believe the prerequisites for that are both of these courses here. Plus, you would take intro biology, 1020H and 1030H. Environmental chemistry, quite similar. Again, you can see there's quite good overlap then between, say, what you would take here and also as a biochem major. Again, intro biochem, choice of physics courses. Here's that half-credit calculus course I talked about. So that's the only one that's required for the environmental chemistry majors. You'd also take biology and the intro environmental science course as well too. And in the wintertime, again, you take a mixture of chemistry. I believe this is the this might be the stats course, if I'm not mistaken, and biology, and then the intro environmental science 2 in the winter term. And so finally, forensics chemistry, and this is an outgrowth of the fact that a lot of forensics actually involves a lot of chemical instrumentation. So this is a fairly recent addition to our set of programs. Would require you to take, again, intro chemistry, both in the fall and winter term. Forensics chemistry, I think one of these is crime scene lab, crime scene investigation, physics and math. And then in the winter term, again, the chemical courses you've seen, I believe this forensic chemistry course might be a law-based course. I'm not a forensic person, but I think this is what you would be taking then. So you take everything that all the other programs take, plus these 2 forensics programs as well too. So again, because all these courses require you to take first-year chemistry, and most, if not all of them, require to take some calculus and physics, it is possible then again to change your major. And you might say, well, I have no interest in changing my major. I know what I want to do. You would be surprised how quickly you change your mind once you come to university. So a lot of people do this. I would say maybe a quarter of the students who come to campus, or perhaps more, actually end up changing their majors, and sometimes in quite a dramatic way. So these sets of programs are quite useful for you, because not only do they allow you to change your major in a chemistry-centered discipline, but you might decide to change to biology. Biology has a requirement for first-year chemistry anyway. So again, if you want to transition, say, out of being a chemistry major to being a biology major, it's fairly easy to do so with this set of courses as well too. So again, for the first 3 years, all the chemistry courses do have labs. You spend a lot of time doing laboratories. And if you're, say, comparing yourself to friends who are in the humanities or something like that, you might say your workload is a lot more because they just have lectures and workshops, and you've got lectures and workshops, and you've got laboratories. And usually in a course, it's like 3 hours of labs a week. So you'll probably be spending a lot of time on campus. But I think that's really a good thing. That's where you actually get to meet people. Us actually, we have shared experience, both good and bad. You can, talk about the things that work. You can talk about the labs you hate. So misery loves company. That's actually part of the experience as well too. But what you're doing here is you're actually working and putting into practice the things you learn in your lectures, right? So you get a chance to practice your lab skills, and practice makes perfect. I mean, this is in some senses research, so we don't expect success right away. And this is where you get a chance to get good at doing these sorts of things. And getting used to failure sometimes in the laboratory is an important thing. And that's what makes a scientist. So research isn't always an uninterrupted series of successes. You have to get used to sometimes things not working for you. And sometimes even when you give your best effort, things just don't work out in the laboratory as well as you would like. So that's okay. It's what you learn from your failures that matters. So in your first year, the labs are quite well defined. So you learn the basics. Second year, this is when you take a lot of different courses we offer. We've got courses in organic chemistry, analytical chemistry, physical chemistry, inorganic chemistry, biochemistry. They all have particular laboratory techniques, and so you get a chance then to see what the techniques are that are most pertinent for those topics. And Year three, it's a continuation of that, but in a more in depth. And so, for example, this for biochemistry, it's in the year three laboratories that you begin to do your own independent work. So one of the major things for one of the biochem courses is you're assigned an enzyme to purify, but you're not told how to do it. And then you have to come up with a way to do that by building on the techniques that you do know, doing some library research, and also talking to other students who've been assigned the same enzymes. So it's a kind of collaborative thing as well too. All those things are involved in constituting science. And that's also the way it's done in some of the other third-year laboratories as well too. And in fourth year, then that's where you do the honors thesis project if you so desire. Like, this is not obligatory to do a fourth year thesis project. But if you like doing research, if you like being a lab rat, this might be for you. And this is where you would approach a professor. You would talk to that person about the kind of research that they do, and then spend time working for credit in that person's laboratory. And so it's actually quite I think, an enjoyable way of earning credit and actually learning how to become a scientist. So that's it. It's time for questions then. And I have to end by showing off. This is the Chemical Sciences building here. It's, I think, a pretty nice one. And again, if you look here, there's that banner. If you've been to Trent before, you know where the bridge is. If you're walking from, say, where the library is across the bridge, you would just look to the right of the center of the bridge, and that's where the Chemical Sciences building is. So you can't miss it. As you walk from one side of the campus to the other one, you're often walking through this building or on top of it as well too, because there's a walkway on top of here that takes you to the other colleges as well too. So I'll stop talking. This would be a good time then for questions.
Amazing. Thank you, Professor Rafferty. And as you mentioned, one thing I like to touch on with this too, yeah, a lot of students do switch. So I know, even being in the program, a lot of my friends switched, and I talked to a lot of incoming students, and they're so nervous about, do I choose this one or this one? And I think it's great that you gave the foundation there, showing that there is a lot of overlap and it's pretty similar as well. So if there's one message I kind of had for students who are worried about coming in, is that not to stress too much, and you'll figure out what you like in that first year and the second year, and you can go from there as well. And then I do see one question I'll touch on here. So would you be able to explain what the difference is between the chemistry degree and a chemical engineering degree?
Okay, Catherine. Actually, I'm kind of double booked because right after this section, like at 1:30, I have to go host a session on chemical engineering. So if you've got the link, we can explain that difference. I don't think I've got the time to do that now, but it's said, well, in brief, chemical engineering is actually chemistry on a large scale, mainly for industrial purposes. And so anything that involves large scale production of, say, of a compound, or movement of a compound, or processing, say, like, I don't know, the petrochemical industry is a major one. Anything that requires factory size chemistry comes under the category of chemical engineering. So I can maybe explain that a bit more in the chemical engineering session if you're going to that one as well too.
Amazing. And then, since we have our students here, I want to hear from both you, Sarah and Kyle. I have a couple questions for you as well. So I'll start with you, Sarah. What do you love most about your program? And before you start, if you want to give like a brief intro to which year you're in and what you're currently doing, that'd be amazing.
Yeah, so my name is Sarah. I am a fourth year biochemistry student. I am currently working on a fourth year undergraduate thesis with Rafferty, which is highly recommended. Part of the reason that I decided to stay on for a master's with Rafferty next year. What I love most about my biochem program is the fact that everything's so hands-on. So right off the bat, first year moving on, you get to be in the lab, you are supervised by wonderful TAs, and the option for that fourth year research course is really valuable, deciding what you want to do after undergraduate. I also like how, especially with the biochemistry program, the classes are a lot smaller. So you get a lot more face time with your professor or with your TAs. And I definitely recommend taking advantage of that, because you can go to an office hour every week and they'll be there and they'll be ready to chat with you about whatever content you have. But there's also the opportunity when you go and take the initiative to talk to your professors, you can also run into, talking about their work. Maybe that means that you're interested in their work and that leads to opportunities for you. So I definitely like that everything is interactive, hands-on, and you get to be very close with your professors.
Amazing. Thanks, Sarah. I totally agree. And that kind of answers one of the questions we just had come into the chat too, just before we go to you, Kyle. It says, how on average, how many students would be in a normal class? And I think one way I would touch on this too is that as we talked about those intro classes, so in your first year, those are going to be bigger classes because not only are biology students going to be taking biology, but so are other students as well, chemistry, biochemistry, maybe physics. Yeah, it depends. Like that big class, you might get a size of 400, 500 students, but don't let that distraught you or make you nervous because you have these lab sizes that get a lot smaller and you get to know your students in your lab sizes. And as you go up, your class sizes get a lot smaller too. So in my fourth year, some of my class sizes were 12 to 13 students, and you really knew everyone in your class as well as the professor. And I don't know if you want to touch on that at all, Professor Rafferty, if I hit that one.
Yeah, the classes do get smaller as you move through. And the other thing too is that the laboratories themselves are smaller still. So depending upon the course, the labs may have I think they would have no more than say 36 students in them for first year, and quite a bit smaller for the other laboratories as well too. So it's not as if you're always with say hundreds of students. It's going to be a lot smaller for most of your experience. I also noticed that somebody had said, if you want to switch majors to health sciences, I would say qualified, yes, because there are a lot of overlap between the courses that we offer and say, I don't think we have a the emphasis in health science. I think that's a specialization in biology, I believe, right? So yeah, I think because you could switch from chemistry to biology, then it should be possible to go into health sciences, assuming that they don't have any particular precondition in terms of course averages and things like that. I mean, we do have the biomedical program as well too, and you can switch between those. We tend to prefer when people switch from biomed into chemistry or biochemistry. So sometimes we've recruited people like that, so that's always good to see. But yeah, in general, it is possible to make these movements. So yeah.
Yeah, exactly. I can touch on the health sciences a bit because I graduated with that specialty. With it, you are able to pick it up in your upper years. And as you mentioned, Professor Rafferty, it is just a matter of picking up courses and making sure you have the average too. There's two kind of options for that. You can do a thesis or course based as well. But again, yeah, it's not something that when you come up in your upper years, you wouldn't be able to switch to as well. It's fairly easy actually, which is awesome. And the good thing about Trent. I'll move on to you next, Kyle, because we didn't quite get to you, but what do you love most about your program here at Trent University?
So I'm also in my fourth year doing honors chemistry. I'm also doing an undergraduate project in the inorganic materials laboratory. And what I do agree with Sarah that my favorite part about the program is just the hands-on lab. I thought it was a really good complementary from your lectures, just applying the theory that you made. And it's really what got me into the research that I do now, more specifically the project labs that I did for main group chemistry. So yeah, through those labs, you get closer to the TAs, and the TAs are usually doing research with professors that run the class, and you get to find opportunities that you are interested in, and that's the easiest way to reach out and experience those.
It's totally true. And it's funny you mentioned that because before our session, we were all kind of chatting about the labs where we had hands-on research and talking about, well, which proteins you have. And it's very interesting to see, and it really gets students excited, and it gives you the unique hands-on experience too. I do have one more question for both of you, but just before we get to that question, in case you have to pop out Professor Rafferty, I was just wondering, who should students get in touch with, or what's the best main contact for these programs if they do want to get in contact with someone?
I would say if you send your email to chemistry@trentu.ca, that's probably the easiest email address to remember. and it will get to the right person. So I'm the undergraduate advisor, so it would ultimately get to me.
Awesome.
And
Thank you.
then I could field your questions.
Okay. Well,
Okay.
thank you.
Okay. Have fun.
Okay. Thank you. The other email I'm going to put in here as well is just our general emails. So discovertrent@trentu.ca or our discovertrentdurham@trentu.ca. Just to mention that if you are thinking of the sciences in particular, like biology, chemistry, biochemistry, those are all offered at our Peterborough campus. That's where our labs are, our main labs. So the Discover Trent is a very good email for that one. Okay, and then I just have one more question for you before we end our session. And this is kind of a big one too. And I'm kind of curious what you guys would say, but what advice would you give for students who are planning to take one of these programs here at Trent University? And I'll start with you, Sarah.
Yeah, so I jotted down a few things. So the first one that I kind of touched on in the last question is definitely take advantage of the time that you have with your professors. Go to office hours. That's part of the reason I ended up with working in Rafferty's lab, was because I'd go to his office hours, I'd ask that one question that I needed to ask, and then we get talking about things. So definitely try and have FaceTime with your professors and be involved with that. I highly recommend a fourth year thesis course. It is the best thing in my undergraduate degree is this thesis course. I am absolutely loving it. And there are a lot of struggles, there are a lot of issues to sort out, but like Rafferty said, that's how you learn. Another recommendation is, especially in your undergraduate labs, those first 3 years, take your time with those labs. One of my biggest regrets is I was so busy, I'd just be like, okay, let's get through this, let's get out, let's go write the lab report, and it was just go, go, go. So take your time. You've got a 3-hour session where you get to learn, you get to make mistakes. So definitely take your time. Biochem can be busy, like we were saying, you've got workshops, you've got lectures, so try your very best to stay very organized. That's a calendar, an agenda. I personally have alerts in my phone that tell me when a deadline's coming up. But kind of straying away from like the academic advice, seeing as it is a pretty strenuous program, definitely take time for yourself as an undergraduate. I got to a point where I'd be, guilting myself into not taking naps because I have something to do, but I'm tired. Take time, take a day on the weekend, whatever it is, even if it means, you're going to lose 5% on an assignment because you needed to take time for your health. Because, if I spent this extra 2 hours, it would be like 5% better. Sometimes you just need to give yourself a break and eat good food. Sometimes it's hard with the calves. Eat good food, drink lots of water, and just stay happy, stay organized. And I think that would really help for me to have known that in the beginning.
Yeah,
So
it's
pass it on. Yeah.
Yeah, it's really made that. Yeah, thank you, Sarah. And it's funny you mentioned naps because me and my best friend were both in this program. And first year we used to nap, and then we gave it up, and then we instantly went back to it our next year. So yeah, that's great advice as well. And one thing you mentioned too is you got to work with Professor Rafferty really closely. And it's just an example of how much our professors really care. If there's one thing I like to say about Trent, and especially Professor Rafferty, is they really do care about your success, and then amazing here at Trent University too. And then I'll just quickly pass it on to you, Kyle, as well.
I think in your first year especially, I'd say look for CHUGS. It's the Chemistry Undergraduate Society. So if you have any, they'll be able to help you with any of the laboratories, with any theory that you're confused about. They have a tutoring schedule, and they have events just to get you into the community of the chemistry students, not just students that are majoring specifically in chemistry, but any biochemistry, forensic chemistry students you'll also find there. So reach out to them and reach out to your TAs especially.
That's great advice. It took me about a year to find CHUGS, and I instantly regretted that I didn't find it faster, because I went almost every week for chemistry help, and it just connects you with other students too. So there's no negative to it, even if you didn't know what you were doing for all the answers and stuff. So yeah, great resources there. But it does look like our time is up here. I do just want to thank both you, Kyle, and Sarah, and Professor Rafferty. I can really feel how much you like the program. And just it is a really unique program as well, and one that you really get close with all your classmates. So I thank you for being here today. If you are watching this and there's anything that maybe we went over and you want to review at a later date, we have recorded our session and we'll be posting those up later on sometime next week. So keep an eye out for those. And we do have in-person open house events happening. So we have open house happening later. We have in-person tours. We especially have a lot of tours happening on March break. So make sure to check those out. I think one of the best ways to know a great university for you is to check it out on campus, and especially see some of those buildings Rafferty was talking about too. So the chemical science building, that's probably where I spent the most of my time in my 4 years. So it's good to see it before you come and yeah, get a sense of it too. So again, thank you for everyone who came and we'll see you hopefully next year or sometime in the future. Okay, well, thank you everyone.